Hello fashion lovers and prospective fashion designers, welcome back to my channel. My name is Daniel Priska, and if today is your first time of visiting this channel, you are very welcome. Alright, today's video is all about one of the most important tools in dressmaking, the tape measure. This is a tape measure. We will explore its key parts, unit of measurement, and how to read it accurately in our sewing project. Now, if this sounds like what you are interested in learning, let's dive into it. So, what exactly is a tape measure? A tape measure is a flexible ruler that is used to measure lengths or distances. Most tape measure features two systems of measurements, the imperial system and the metric system. The imperial system uses inches as its unit of measurement, while the metric system uses centimeters and millimeters. In the fashion industry, a tape measure is an indispensable tool for every fashion designer. This is because whether they are taking body measurements, marking fabrics, or creating patterns, they must use this basic tool. Now, note that precision is key in fashion design, and as a fashion designer, every single tool you use contributes to the accuracy of your designs. Hence, without proper understanding of how to use a tool, you may find it difficult to use such a tool in expressing your design ideas clearly. Okay, let's take a closer look at the essential components of a tape measure and why they are so important for your fashion journey. The essential components of a tape measure are basically the main parts that make up the tape so effective in measuring body dimensions and garment pieces. The first essential component to be discussed is the metal tip at the beginning and end of the tape. This is the metal tip at the beginning of the tape, while this is the metal tip at the end of the tape. The metal tip at the beginning of the tape is the starting point for taking measurements. It marks zero and ensures accuracy when measuring. Again, this metal tip is intentionally designed to be slightly loose and should not be removed for any reason before taking measurements, because it is a functional design that helps you take accurate measurements. Another reason why you should not remove this metal tip before using the tape measure to take body measurements is because removing it could also cause damage to the starting point of the tape. Now take a look at this tape. It's damaged at the starting point because I removed the metal tape. See that this tape is no longer in good condition for it to be used to take accurate body measurements. So this is one of the reasons why you should not remove this metal tip from the start point of the tape. This brings us to the second essential component, which is the flexible tape. The flexible tape is simply the main body of the tape. It is made from materials like fiberglass, fabrics, or plastics, and these materials allow the tape measure to bend and wrap around curves, which is essential when you are taking body measurements or working on patterns. The tape measure used in this video is made from fiberglass, and it is indicated on it. Between 1 inch and 2 inches is a write-up called fiberglass. The essence of this write-up is to indicate the material used to make the tape. The third essential component to be discussed is the tape length indicator. The tape length indicator shows the maximum length of the tape. It could be marked on the tape or even printed on the casing for tape with casing. For instance, on this tape measure is a 60-inch notation, which is found between 3 and 4 inches. It shows the total length of the tape. Why is it important that you should know the maximum length of your tape measure? It is important because It will help you to avoid taking measurements which are beyond the tape's limit. The fourth essential component, which is the most crucial of any tape measure, is the measurement markings or scale marked or graduations. The measurement markings are the actual unit of measurements on the tape measure, and they are what allows you to read your measurement accurately and with ease. On the imperial system, which is the part of the tape measure calibrated in inches, and it is this part that is displayed on the screen, there are basically two units of measurements: the whole inches and fractions of the whole inch. The whole inches are the primary units on the imperial system. They are the large bolded numbers labeled 1, 2, 3, 4, 5 up to 60 inches. They are 1 inch spaced apart. That is, every full number marking on the tape measure 1, 2, 3 up to 60 inches is separated by a distance of exactly 1 inch. Fractions of the whole inch are the smaller divisions within every whole inch, which allows for more precise measurements. Common examples of the fractions of the whole inch include half inch, quarter inch, 1/8 inch, and even 1/16 inch on some tapes. But in relation to the tape measure used in this video, every whole inch is subdivided into 8 equal parts, giving us fractions like 1/8 inch, quarter inch, 3/8 inch, half inch, 5/8 inch, 3/4 inch, and 7/8 inch. So, to illustrate how the imperial system divides inches, this drafted segment of the tape measure from the start point to 2 inches will be used as a guide. From the starting point up to 1 inch will be used to illustrate the values of each of these 8 smaller divisions found between every 2 whole inches, while from 1 inch to 2 inches will be used to illustrate the increment as we count along the tape measure. Note that when you are counting these 8 smaller divisions found between every 2 whole inches, you start counting from the first smaller line after every whole inch and continue counting until you reach the next inch. Now, consider the start point up to 1 inch. We will start counting from here, and we will have these 8 smaller lines as 1, 2, 3, 4, 5, 6, 7, 8. Let's proceed into learning their values in fractional and decimal equivalence. The first smaller line after every whole inch mark is 1/8 inch. The second line is quarter inch. The third line is 3/8 inch. The fourth line is half inch. The fifth line is 5/8 inch. The sixth line is 3/4 inch. The seventh line is 7/8 inch. And the eighth line is the next whole inch mark, which is 1 inch in this case. Why is this first line 1/8 inch? It is 1/8 inch because it represents one part out of the 8 equal parts that the entire whole inch was subdivided into. It cannot be simplified more than this, so we will leave it as 1/8, which is read as 1/8 inch. The second line is quarter inch because it represents 2 parts out of the 8 equal parts that the entire whole inch was subdivided into. When it is simplified to its lowest term, it becomes 1/4. That is, 2 will divide 2 to get 1, and 2 will divide 8 to get 4. The third line is 3/8 inch because it represents 3 parts out of the 8 equal parts that the entire whole inch was subdivided into. It cannot be simplified more than this, so we will leave it as 3/8, which is read as 3/8 inch. The fourth line is ½ inch because it represents 4 parts out of the 8 equal parts that the entire whole inch was subdivided into. When it is simplified to its lowest term, it becomes 1/2. That is, 4 will divide 4 to get 1, and 4 will divide 8 to get 2. The fifth line is 5/8 inch because it represents 5 parts out of the 8 equal parts that the entire whole inch was subdivided into. It cannot be simplified more than this, so we will leave it as 5/8, which is read as 5/8 inch. The sixth line is 3/4 inch because it represents 6 parts out of the 8 equal parts that the entire whole inch was subdivided into. When it is simplified to its lowest term, it becomes 3/4. That is, 2 will divide 6 to get 3, and 2 will divide 8 to get 4. The seventh line is 7/8 inch because it represents 7 parts out of the 8 equal parts that the entire whole inch was subdivided into. It cannot be simplified more than this, so we will leave it as 7/8, which is read as 7/8 inch. And finally, the eighth line is the whole inch mark, which is 1 inch in this case. Now that we've talked about the values of each of these 8 smaller lines found between every 2 whole inches in fractional form, we will proceed into learning their values in decimal equivalence. The first line is equivalent to 0.125 in decimal number. The second line is equivalent to 0.25. The third line is equivalent to 0.375. The fourth line is equivalent to 0.5. The fifth line is equivalent to 0.625. The sixth line is equivalent to 0.75. The seventh line is equivalent to 0.875, while the eighth line is the whole inch mark, which is 1. Now, let's consider the parts that we'll be using to illustrate the increment as we count along the tape measure, that is, between 1 inch and 2 inches. After the whole inch mark, that is, after 1 inch mark, the next smaller line is 1/1/8 inch. The second line is 1¼ inch. The third line is 1¾ inch. The fourth line is 1½ inch. The fifth line is 1⅕ inch. The sixth line is 1¾ inch. The seventh line is 1⅞ inch, while the eighth line is the whole inch mark, which is 2 inches. Now, let's proceed to their values in decimal numbers. After the whole inch mark, the first smaller line is equivalent to 1.125. The second line is 1.25. The third line is 1.375. The fourth line is 1.5. The fifth line is 1.625. The sixth line is 1.75. The seventh line is 1.875. And the eighth line is 2 inches. Why is this first smaller line after the 1 inch mark 1.125? It is 1.125 because the value of the first smaller line after every whole inch mark is equivalent to 0.125. Now, after 1 inch, it becomes 1.125 because the value of the first smaller line after every whole inch mark will be added to 1 inch. And if we do that, we will have it as 1 plus 0.125, which will give us 1.125. The second line is 1.25 because the value of the second line after every whole inch mark is 0.25. So when it is added to 1 inch, it becomes 0.25 plus 1, which will give us 1.25. So that is the reason why this second line after the 1 inch mark is equivalent to 1.25. To the third line, it is equivalent to 1.375 because the value of the third line after every whole inch mark is equivalent to 0.375. So when it is added to 1 inch, it becomes 0.375 plus 1, which will give us 1.375. The fourth line is 1.5 because the value of the fourth line after every whole inch mark is equal to 0.5. When it is added to 1 inch, it becomes 0.5 plus 1, which will give us 1.5. The fifth line is equivalent to 1.625 because the value of the fifth line after every whole inch mark is equivalent to 0.625. So when it is added to 1 inch, it becomes 0.625 plus 1, which will give us 1.625. The sixth line is 1.75 because the value of the sixth line after every whole inch mark is equivalent to 0.75. When it is added to 1 inch, it becomes 0.75 plus 1, which will give us 1.75. The seventh line is equivalent to 1.875 because the value of the seventh line after every whole inch mark is 0.875. When it is added to 1, it becomes 0.875 plus 1, which will give us 1.875. And the eighth line is the 2 inches mark. So this is all that you need to know about the divisions on the tape measure in relation to the imperial system. In summary, we've talked about the meaning of a tape measure, the essential components of a tape measure, the divisions on the tape measure, and the values of these divisions in both fractional and decimal equivalents. Thank you for watching this video to the end. And if you found this video helpful, please like and share this video. God bless you. See you in our next video. Bye.